Good morning, everyone, and I am Alekhya. Today I am going to teach you about the concepts of electromagnetic waves. So, coming to the concepts of these waves, our first chapter is electrostatic fields, right? So, before going to these topics, first of all, we should know about what do you mean of a wave, what are the types of waves. So, we should know about the fundamentals of these waves. So coming to wave, a wave is nothing but transportation of energy from one place to another place. Energy and momentum, not only energy, energy and momentum from one place to another place. So in other words, it is also defined as a disturbance created in a medium is also called as a wave. So these waves are generally classified into two types. Those are mechanical waves, non-mechanical waves. What do you mean of mechanical wave? For this propagation of data from one place to another place, sometimes we requires a medium. That medium dependent propagation is nothing but mechanical waves. And coming to non-mechanical waves, which doesn't requires any medium for its propagation, like free space is a medium. So coming to these categories, how we are going to describe the types of waves, like mechanical waves again classified into longitudinal waves. So what do you mean of longitudinal wave? That is nothing but like a compression and rarefaction can be happened in between the waves. If it is a longitudinal wave. If it is a transverse wave, what happens? It is now the concept is related with crusts and troughs. Okay, so the wave can be handled in between crust and trough. And now I am going to introduce the topic of what do you mean of wavelength. By using these waves only, here I am going to introduce wavelength. The distance between two successive crusts or two successive troughs is also called as a wavelength. So how we are going to define this wavelength of a wave? That is nothing but V equals to n lambda. How many number of wavelengths is covered? That can be described by using our wave velocity. V equals to n lambda. N number of wavelengths can be completed here. That can be used to describe our wave velocity. So now the concepts of electromagnetic waves can be handled with the help of these electrostatic fields as well as magnetostatic fields. Before going to the concepts of Maxwell's equations like electromagnetic time varying fields, before that we should learn about what do you mean of electrostatic field and what do you mean of magnetostatic field. So my motto is today's class is to I am going to handle with electrostatic fields. Okay, so what do you mean of electrostatic? The term static. Static is nothing but constant position. When a charge is located at constant position, what type of forces can be placed here? That the phenomena can be happened with the help of our Coulomb's law. Let me take two constant charges located at Q1 and Q2 are my constant charges. Both are located at some distance r. Now the force acting between these two constant charges can be described by using Coulomb's law. That is nothing but, see here, I have represented by using this slide, F equals to Q1 Q2 by R square, where Q1 is some constant charge, Q2 is some constant charge, and both charges are located with distance r, and this is the material constant, that is K. K equals to 1 by 4 pi epsilon naught. This is a constant value where epsilon naught is the permittivity of the material. Already we know that constant value 8.854 into 10 to the power minus 12 farad per meter. Right? So by using this Coulomb's law, we can able to calculate the force between two constant charges. So here, according to our fundamentals of electromagnetic waves, how we are going to describe a point in free space? How we are going to analyze the point? If it is located in free space, how we are going to calculate? By using coordinating systems, we can able to calculate the mathematical calculations, like we have rectangular coordinating system, circular coordinating system and spherical coordinating system. So what do you mean of a coordinating system? Coordinating system is nothing but which is used to represent a point located in free space. A point located in free space that can be represented by using our coordinating systems. So these coordinating systems are differ from each other. First one is rectangular coordinating system. The space variables of rectangular coordinating system is different as compared with remaining, and as well as for all the coordinating systems, rectangular coordinating system is the very fundamental coordinating system. Any other coordinating system which is made by using this rectangular coordinating system. So here basically rectangular coordinating system is consists of x, y, z are the axis representation, ax, ay, az are the directional representations of our rectangular coordinating system. So here by using this rectangular, here I am going to consider some origin. So here free space. So that free space can be considered by using some origin point. That origin can be taken according to our coordinating systems. Now here origin to constant charge q1 distance is r1, and here origin to constant charge q2 distance is r2. If I am going to consider vector calculus for this phenomena, so I am going to have equation is force between two constant charges is directly proportional to each other, and that same force is inversely proportional to the distance between the both constant charges. So here not only distance, square of the distance between the both constant charges. So this Coulomb's force law is very important law for very fundamental law for electrostatic fields. By using this Coulomb's law, I am going to describe electric field intensity. This electric field intensity is nothing but force per unit charge. That force is nothing but Coulomb's force per unit charge that can be described by using our Coulomb's force, right? So this is our fundamental Coulomb's law equation, F equals to Q1 Q2 by R square. If I am going to consider vector calculus, this is my equation, F12 equals to Q1 Q2 R2 minus R1 by 4 pi epsilon naught R2 minus R1 whole cube. If I am going to consider vector calculus for the respective equation, this is my final expression, right? So let me go for the next slide. So as I told you, the fundamental laws of electric field intensity can be defined by using our Coulomb's force. Okay, so this is nothing but electric field intensity is force per unit charge. Force per unit charge. Here I am going to apply electric force what we have defined previously. I have substituted here. So now I got final equation as E equals to F by Q. So by using that we are going to get final conclusion equation. So now I am going to describe what are the types of charge distributions we have. Okay. So now according to our charge distributions, here we are going to have point charge distribution, line charge distribution, surface charge distribution and volume charge distribution. So now here see point charge distribution which doesn't occupies any space, right? Example is like electron is a like negative charge. That electron is a one of the example for point charge distribution. If it is a line charge, a charge can be distributed along the length of the element. So which can be occupied with length of the element. So simply charge can be measured in terms of coulombs, whereas when I am going to consider L length of the element, units are coulomb per meter, which is occupied with length of the element. And here coming to surface charge distribution, here charge can be distributed along the surface which is occupied with length as well as breadth. So here units are coulomb per meter square, right? So next one is final one is volume charge distribution. Here charge can be distributed along the length, width as well as height of the element. That's why here units of the volume charge is nothing but coulomb per meter cube, right? And let me consider differential charge here. If I have L length of charge, some part of this charge distribution can be represented as dq. Entire charge is q, some part is dq. Entire length is L, some part is dl. Like that way here I have represented like dq equals to rho L dl. What do you mean of rho L? Line charge distribution. Charge per unit length is called as line charge distribution. Here I have represented in the form of differential equation like dq equals to rho L dl. Finally q equals to line integral rho L dl. In the same way, if it is surface, I am going to consider this value as dq equals to rho s ds. So q equals to surface integral rho s ds. Here I am going to represent units for each and every charge. Like if it is volume charge means the equation becomes dq equals to volume integral means rho v dv. That charge equation becomes q equals to volume integral rho v dv. Units are coulomb per meter cube. This is all about continuous charge distribution with respect to electric field, right? So here we are going to have different problems related to this Coulomb's force, electric field intensity with respect to different charge distributions. So remaining concepts we'll discuss in the next class. Yeah, thank you so much. Thank you all.